Hello everyone, I am Mrs.K.DEVI, Department of Computer Science, A.D.M.COLLEGE for Women Autonomous, NAGAPATTINAM. Now discuss about the topic database NoSQL. First one, what is MongoDB? The MongoDB is a document-oriented NoSQL database used for high-volume data storage. Instead of using tables and rows as in the traditional relational database, MongoDB makes use of collection of documents. The document consists of key value pair, which are the basic unit of data in Mongo database. MongoDB database features. Each database contains collections which in the turn contains of documents. Each document can be different with the varying number of fields. The size and content of each document can be different from each others. The document structure is more in line with how developers construct their classes and objects in the respective programming language. Developers will often say that the classes are not row and column but have the clear structure with key value pairs. The row or document as called in the MongoDB does not need to have the scheme defined beforehand. Instead, the field can be created on fly. The data model available within MongoDB allows you to represent hierarchical relationship, to store array and other more complex structure more easily. Scalability. The MongoDB environment are very scalable. Companies across the world have found the cluster with some of them running 100+ nodes with around million of documents within the database. Key components of MongoDB architecture. The ID, this is the field required in every MongoDB document. The ID field represents the unique value in the MongoDB document. The ID field is like the document primary key. If you create a new document with an ID field, MongoDB will automatically create the field. So for the example, if we see the example of above the customer table, MongoDB will add the 24-digit unique identifiers to each document in the collections. ID, customer name, customer order ID. This is for the example. The next one is collection. This is the grouping of MongoDB document. A collection is the equivalent of table which is created in any other RDBMS such as Oracle or MS SQL. A collection exists within a single database. As seen from the introduction, collection does not enforce any sort of structures. The next one is cursor. This is a pointer to result set of a query. Client can iterate through the cursor to retrieve the result. Database. This is the container of collections like in RDBMS, wherein it is a container of tables. Each database get its own set of fields on the file system. A MongoDB server can store the multiple database. Documents. A record in a MongoDB collection is basically called a document. The document in turn will consist of field name and values. The next one is field. The name value pair in a document. A document has 0 or more field. field are analog to column. Relation database. The following diagram shows an example of field with key value pairs. So, in the example below the customer ID and is the one of the key value pairs define the document. For the example, the customer ID is 11, the customer name is group, next the order ID is 111. These are the key value of pairs. The database revolution. The molecular biology and genetics, the high throughput data gathering has progressed in the short time from the novel strategy of the few to standard approach of many. Much of this data are not collected into way to guarantee their accessibility to other researchers for future analysis. The best database, however, are online of raw and processed data analytics tools and insights that have been collectively dubbed the knowledge of environment. Funding agencies are slowly adjusting their priorities to reflect the importance of the consistency. Assured support for some of these databases. The US National Institute of Health, for the example, has organized that it must provide the guidance for its research section and guarantee so as to maximize the turn in both knowledge and public health on its investment in the biomedical research. Which strategy best support the collections, analysis and dimension of large database? The knowledge environment promote the aim of funding agency. At the meeting in the month of it is clear that NIH the struggling to find the middle road between two diametrical proposed approaches to the development of such database. The top-down pressure by the agency on the researchers to use certain software or format would probably impede their development. But the bottom-up strategy that merely encourages cross-project cooperation while allowing researchers totally freedom to devise their own database is bound to be there, does not guarantee across the compatibility of data and ultimately reduce to likelihood that the content will be used to maximally benefit research. What is clear is that individual labs can no longer make much progress alone. Currently, many researchers feel that drawing the data. For all they know, the database might contain answers to patient safety issues or glimmers of few therapies, but this is being lost through the inability of effectively harvest the data already available. The another opportunities are missed because both expert and data are siloed in the isolated and often inaccessible system. On top of these issues is the fact that neither database nor expert that create them or prevented the inseparable. The NIST and its equivalent agency elsewhere in the world are now turning their attention to working out how best assist the growth of validate and accessible databases. This should involve at least development of policies of evaluating proposal on database and associated analytic tools for their sustained funding and for ensuring that the data deposited remaining accessible along after the project ordinary have moved on. All funders should also be aware from the need to support available career path for the software engineering and bioinformaticians who create the knowledge environment and create the data in them, and in order to obtain value of money. It will vital of funding agency to carefully select the database they choose support and then support them for long term. They must encourage the sustained availability of these data and build incentive for the development across the query capability. As things standard, even popular database such as for the facing loss of NIH funding after 7 years in the development, often lack secure funding. In order to get value, the NIH and other funding agency need to develop policy for such knowledge environment that will allow long-term support of successful ones. Researchers also need the stronger incentive to sustain their own participation in the building knowledge environments. At the minimum contribution should receive equitable knowledge of depositions, leadership and trust are required to ensure the primary researcher personally benefit from storing the data in open database. Mitchell, the Associate Director of National Institute of Mental Health, told those at the meeting that the NIH is keen to get more milestone of the high throughput data occurring without public fund. But that will mean that the agency should require database it is support to equipped with the tools and protocols that research the fund convenience to use. Ultimately, these databases must show that their data are being used by other groups and generating work for publishable quality. System architecture. ID, this is the field required every MongoDB document. The ID field represents the unique key value in the MongoDB document. The ID field, like the document, is the primary key. If you create a new document without an ID field, the JSON, this is known as the JavaScript object notation. This is a human readable plain text format for expressing structured data. JSON is currently supported in many programming languages. Just a quick note on key difference between the ID field and the normal collection field. Next, why use MongoDB? Document oriented. Since MongoDB is a NoSQL type database, instead of having data in a relational type format, it stores the data in document. This makes MongoDB very flexible and adaptable to real business world institution of the requirements. The ad hoc queries. MongoDB support the search by field, managing queries and regular expressions research. Queries can be made to return specific field within document. Indexing. Index can be created to improve the performance of research within database. Any field in the MongoDB document can be indexed. Replication. MongoDB can be provide high availability with the replica set. The replica set consists of 2 or more MongoDB instances. Each replica set member may act in the role of the primary or secondary replica at any time. The primary replica is the main server, which interact with the client and perform all the read-write operations. The secondary replicas maintain a copy of the data of primary using built-in the replication. When a primary replica fails, the replica set automatically switches over to the secondary and then it becomes the primary server. Loading balancing. MongoDB uses the concept of sharding to scale horizontally by splitting the data across multiple MongoDB instances. The MongoDB can run over multiple servers, balancing the load and or duplicating data to keep the system up the running in case of handover failures. Data modeling in MongoDB. What are the need of applications? Look at the business need of applications and see what data and the type of data needed for applications. Based on this, ensure that the structure of the document is decided accordingly. What are the retrieval patterns? If you possess a heavy query usage, then consider the use of index in your data model to improve the efficiency of queries. Or frequent insert, update and removal happening in the database, reconsider the use of index or incorporate sharding if required in your data modeling design to improve the efficiency of your overall MongoDB environment. The next one is difference between MongoDB and the relational database management systems. The relational management system is stable. The MongoDB is a collection. Difference is the RDBMS, the table contains the column and rows which are used to store data, whereas in MongoDB, the same structure is known as the collection. The collection contains document which in the turn contain the field within the turn or key value pairs. The RDBMS is row, the MongoDB is a document. The row represents the single implicit structured data item in the table. The MongoDB, the data is stored in the document. The RDBMS is the column, the MongoDB is the field. The column denotes the set of data value. These in MongoDB are known as the field. The RDBMS joins the MongoDB is embedded document. The data is sometimes spread across various tables and in order to show complete view of all data, a join is sometimes formed across table to get data. The MongoDB, the data is normally stored in the single collection but separated by using embedded documents. So, there is no concept of joins in MongoDB. The relational database are known as for enforcing the data integrity. This is not an explicit requirement of MongoDB. The RDBMS requires that data can be normalized first so that it can prevent urban record and duplicate normalization. The data then has the record for more tables, which will then result in the more table join that requiring more keys and indexing. As database start to grow, performance can start becoming an issue. Again, this is not an explicit requirement in MongoDB. MongoDB is flexible and does not need the data to be normalized. Thank you all.